Rocks are like puzzle pieces. Each one is a fragment of a larger story, a chapter in the grand narrative of our planet. They come in all shapes, sizes and colors, each with its own unique characteristics and history. When we look closely at rocks, we can see the intricate details that tell us about the conditions under which they formed. From the tiniest grain of sand to the largest boulder, every rock has a tale to tell. They tell us the story of Earth. Over billions of years, our planet has undergone dramatic transformations. Mountains have risen and eroded away, oceans have come and gone, and entire continents have shifted. Rocks are the silent witnesses to these changes, preserving the evidence of Earth's dynamic history. By studying rocks, we can piece together the events that have shaped our world. Each rock holds clues about our planet's past. Geologists, like detectives, examine these clues to understand the processes that have shaped the Earth. They look at the composition, texture and structure of rocks to decipher their origins. For example, sedimentary rocks can reveal information about ancient environments, while metamorphic rocks tell us about the intense heat and pressure that transformed them. Some rocks tell us about fiery volcanoes. Igneous rocks, formed from molten magma, provide a glimpse into the Earth's fiery interior. When a volcano erupts, it spews out lava that cools and solidifies into rock. These rocks can be found all over the world, from the black sands of Hawaii to the rugged landscapes of Iceland. They remind us of the powerful forces at work beneath our feet. Others tell us about ancient oceans. Sedimentary rocks, formed from layers of sediment, often contain fossils that provide a window into the past. These rocks can tell us about the creatures that once lived in ancient seas, the climates they experienced, and the environments they inhabited. By studying these rocks, we can learn about the history of life on Earth and how it has evolved over time. By studying rocks, we learn how Earth has changed over millions of years. The rock record is like a time capsule, preserving the evidence of past events. From the formation of the first continents to the rise of the Himalayas, rocks have recorded it all. By analyzing these records, geologists can reconstruct the history of our planet and gain insights into the processes that continue to shape it today. It's a fascinating journey through time. As we explore the world of rocks, we uncover the secrets of Earth's past and gain a deeper appreciation for the dynamic planet we call home. Each rock is a piece of the puzzle, helping us to understand the complex and ever-changing nature of our world. So let's embark on this journey together and discover the stories that rocks have to tell. Let's explore the main types of rocks and the stories they tell. There are three primary types of rocks: igneous, sedimentary, and metamorphic. Each type forms under different conditions and tells a different part of Earth's story. By examining these rocks, we can learn about the processes that have shaped our planet and the environments that have existed throughout its history. We begin our journey with igneous rocks, born from the heart of volcanic activity. These rocks form when molten magma cools and solidifies, either beneath the Earth's surface or after being erupted from a volcano. Igneous rocks can be found in a variety of settings, from the ocean floor to the peaks of mountains. They provide valuable information about the Earth's interior and the processes that drive volcanic activity. Imagine a volcano erupting. Molten rock called magma bursts from the Earth. When magma cools and hardens, it forms igneous rocks. There are two types of igneous rocks. Rocks that cool quickly above ground are called extrusive rocks. Basalt, with its dark color, is a common extrusive rock. Rocks that cool slowly underground are called intrusive rocks. Granite, often used for buildings, is a well-known intrusive rock. Rivers carry tiny bits of rock and sand. These tiny particles, known as sediments, are often carried over long distances by the flowing water. As the river moves, it picks up more and more of these particles, which can include not just sand and rock, but also bits of organic material like leaves and small pieces of plants. The journey of these sediments can be quite extensive, sometimes spanning hundreds of miles before they finally come to rest. Over time, these sediments settle at the bottom of lakes and oceans. This process is gradual and can take thousands or even millions of years. As the sediments accumulate, they form distinct layers, each one representing a different period in Earth's history. These layers can tell us a lot about the environment at the time they were deposited, such as the climate, the types of organisms that lived there, and even events like volcanic eruptions or floods. Layer upon layer builds up. Each new layer of sediment adds weight and pressure to the layers beneath it. This pressure is a key factor in the formation of sedimentary rocks. Over long periods, the weight of the accumulating layers compresses the sediments below, squeezing out water and compacting the particles together. This process, known as lithification, transforms the loose sediments into solid rock. The weight presses the layers into solid rock. These are sedimentary rocks. They are characterized by their distinct layers, which can often be seen with the naked eye. These layers, or strata, are a record of the Earth's geological history, capturing moments in time when different types of sediments were deposited. Sedimentary rocks are incredibly important to geologists because they provide a window into the past, helping us understand how our planet has changed over millions of years. Fossils are found in sedimentary rocks. These fossils are the remains or traces of ancient organisms that were buried by sediments and preserved over time. The conditions in sedimentary environments are often ideal for fossilization because the sediments can quickly cover and protect the remains from decay and scavenging. Fossils can range from tiny microorganisms to large dinosaurs, providing a fascinating glimpse into the diversity of life that once existed on Earth. Fossils are the preserved remains of ancient plants and animals. They can include bones, shells, leaves, and even footprints. Studying these fossils allows scientists to reconstruct ancient ecosystems and understand how life on Earth has evolved over time. Fossils found in sedimentary rocks have been crucial in piecing together the history of life, revealing how different species have adapted to changing environments and how major events like mass extinctions have shaped the course of evolution. The Grand Canyon is a famous place to see sedimentary rock layers and fossils. The canyon's walls expose a cross-section of Earth's crust, revealing nearly 2 billion years of geological history. The distinct layers of sedimentary rock in the Grand Canyon tell a story of ancient seas, rivers, and deserts that once covered the region. Fossils found in these layers provide evidence of the diverse life forms that inhabited these environments, making the Grand Canyon a valuable site for both geologists and paleontologists. Sandstone, made from sand grains, is a common sedimentary rock. It forms in environments where sand is deposited, such as beaches, deserts, and riverbeds. The grains of sand are often cemented together by minerals like quartz or calcite, giving sandstone its characteristic hardness and durability. Sandstone can vary in color, from white and yellow to red and brown, depending on the minerals it contains. It is widely used in construction and as a decorative stone because of its attractive appearance and strength. Another is limestone, formed from the shells of sea creatures. Limestone is primarily composed of calcium carbonate, which comes from the skeletal remains of marine organisms like corals, mollusks, and foraminifera. Over time, these remains accumulate on the ocean floor and are compacted into solid rock. Limestone is often rich in fossils and can provide valuable information about ancient marine environments. It is also an important resource for human use, being a key ingredient in cement and a popular material for building and sculpture. Deep inside the Earth, heat and pressure can change rocks. This process, known as metamorphism, alters the mineral composition and structure of the rocks. The intense conditions can cause profound physical and chemical changes, transforming the original rock into a new type. These changes occur over millions of years, driven by the immense forces within the Earth's crust. The result is a diverse array of metamorphic rocks, each with unique characteristics and properties. Igneous rocks and sedimentary rocks can transform into metamorphic rocks. This transformation is a testament to the dynamic nature of our planet. Igneous rocks formed from cooled magma or lava, and sedimentary rocks created from accumulated sediments undergo significant changes when subjected to heat and pressure. The minerals within these rocks recrystallize, forming new textures and structures. This process can create rocks that are harder, denser, and more resistant to weathering. The word metamorphic means changed form. This aptly describes the transformation that these rocks undergo. The original rock, known as the protolith, is altered in such a way that its original characteristics are often unrecognizable. The new rock exhibits features that are distinct from its precursor, showcasing the power of geological processes. This transformation is not just a superficial change, but a complete reorganization of the rock's internal structure. Marble is a metamorphic rock formed from limestone. When limestone is subjected to high temperatures and pressures, it recrystallizes to form marble. This process enhances the rock's durability and beauty, making it a popular choice for construction and art. The fine-grained texture and ability to take a high polish make marble a favorite material for sculptors and architects. Its use dates back to ancient civilizations, where it was prized for its aesthetic appeal and structural integrity. It is often used in buildings and sculptures. Slate is another example. Slate forms from shale, a sedimentary rock, through low-grade metamorphism. This process aligns the minerals within the rock, giving slate its characteristic foliation and ability to split into thin, durable sheets. These properties make slate an ideal material for roofing tiles, flooring, and other applications where strength and weather resistance are important. It comes from shale, a sedimentary rock. Shale is composed of clay minerals and fine particles that have been compacted over time. When shale is subjected to heat and pressure, it transforms into slate. This metamorphic process enhances the rock's durability and gives it a unique texture. The fine layers within slate are a testament to its sedimentary origins, while its strength and resilience are a result of the metamorphic forces that shaped it. Slate is strong and flat, ideal for roofing tiles. Its ability to withstand harsh weather conditions and its natural beauty make it a popular choice for both functional and decorative purposes. The fine-grained texture and subtle color variations add a touch of elegance to any structure. Slate's durability ensures that it can last for decades, providing reliable protection and aesthetic appeal. Metamorphic rocks often have beautiful patterns and colors. These patterns are the result of the complex interplay of minerals during the metamorphic process. The heat and pressure cause the minerals to recrystallize, forming intricate designs and vibrant hues. Each metamorphic rock tells a story of its geological history, with its unique patterns and colors serving as a record of the conditions it experienced deep within the earth. The heat and pressure create swirling designs and sparkling crystals. These features are not only visually stunning but also provide valuable information about the rock's formation. The presence of certain minerals and the specific patterns they form can reveal details about the temperature and pressure conditions during metamorphism. Metamorphic rocks are a testament to the dynamic and ever-changing nature of our planet, showcasing the incredible power of geological processes. Rocks are made of minerals. Minerals give rocks their colors and textures. Some minerals, like quartz, are clear and shiny. Others, like feldspar, come in many colors. Minerals have different properties. Some are hard, like diamonds. Others are soft, like talc. Some minerals, like gold, are valuable. Section 6, Rock Detectives, uncovering clues from the past. Geologists are scientists who study rocks. They're like detectives. They use rocks to understand Earth's history. Fossils in rocks tell us what kind of plants and animals lived long ago. The layers of sedimentary rocks tell us about past environments. By studying rocks, we learn about ancient climates, oceans, and continents. Section 7. Rocks in our lives. From buildings to smartphones, we use rocks every day. Buildings, roads, and bridges are made with rocks. We use rocks to make glass, concrete, and even toothpaste. Smartphones contain minerals from rocks. These minerals help our phones to work. Rocks are essential resources for our modern lives. Section 8. Fun facts about rocks, trivia from the Stone Age. Did you know the largest diamond ever found weighed more than a baseball? Some rocks float on water. Pumice, a type of igneous rock, is light enough to float. The Earth's crust is made of giant plates of rock that move very slowly. Rocks are full of surprises. Section 9. Keep exploring. The rock cycle continues. Rocks are constantly changing. It's a cycle. Igneous rocks can break down into sediment. Sedimentary rocks can be buried and transformed. Metamorphic rocks can be uplifted and weathered. The rock cycle never ends. Keep exploring the world of rocks and discover the secrets they hold.